Bismillahirrahmanirrahim. Guys, we shall be first of all talking about the relationship a line can have with a plane. Okay? Imagine there is a plane. Okay? There is a plane like this. Okay? There is a plane over here. And then there is a line. Okay. Do you have any idea what can be the relations between a line and a plane? Hmm?
It can either pass through or it can lay on it.
Okay, first of all, very good. First of all, the line can pass through the plane. Okay, a line can pass through the plane. Okay, what else?
It can lay on the plane.
Yeah, it can be lying on the plane. Okay, what else? Hmm?
That's it.
Yes?
It can be parallel.
Yeah, it can be parallel to the line, parallel to the plane. So these are the three cases, these are the three relations that a line can have with the plane. So let's discuss this. देखिए, whatever you have to do in all these three cases, you need to have the this equation of the line in its parametric form. Okay, so like this line, we have been given the equation of a line here. It says show that this lies in this plane. Okay, so we have x equal to 1 plus 2t. Then you have y equal to minus 1. I think that is 1 minus 1. That's it. And then you have z equal to um, 8 minus t. Okay? Acha. If your line is parallel to the plane, if your line is parallel to the plane, you can simply see that the direction vector of the line is 2, 0, minus 1. Okay? And you do its dot product with the normal to the plane, which is 1, 5, 2. 1, 5, 2. So this is going to be like this is 2 minus 2. You see that is equal to 0. So a line can be parallel to the plane, or if it is lying on the plane in both the cases, like for example, you have a line over here, which is like, this is parallel to the plane, and there is a line which is, let's say, lying on the plane, like let's say it's like this. Okay, now if you draw the normal onto like, suppose this is the normal to the plane over here. Okay, or this is the normal to the plane, like, going like this. Okay, so if this yellow line is the normal to the plane, you see it is going to be perpendicular to both of the lines. Either it's lying on the plane or it is just parallel to the plane. So this dot product between the direction vector of the line and the normal to the plane will be 0. So how would you determine if the line really lies on the plane? So guys, you will have to substitute x, y, z into the equation of the plane. Okay, so in fact there are two ways of doing it. The first method is you just substitute this x, y, z into the equation of the plane. You see, you get if I substitute this into the plane, I get 1 plus 2t. Then I have 5 into minus 1, and then I have plus 2 into 8 minus t. And you will see that this will be equal to 12. This is 1 plus 2t minus 5 plus 16 minus 2t, that is equal to 12. 2t is cancelled with the 2t, and this is going to be 12 equal to 12. So you can note it down for your notes that if a line lies in the plane, you substitute the x, y, z of the line into the plane, you will obtain an identity. it is absolutely the same as you were doing in your O levels. Like suppose if you have y equal to 2x plus 3, and suppose you have to check if 1 comma 5 is lying on this line or not. So if you substitute this point into this equation, so you always end up with an identity. Okay? Acha. So this was one way of verifying if a line really lies on the plane. You substitute the x, y, z into the plane, you end up with an identity. Okay, you can do this in two steps as well. Like if you first of all find the direction vector find the dot product between the direction vector of the line and the normal to the plane, this will be first of all 0. And secondly, if you substitute this point, which is this 1 minus 1 8 into the plane, you will see that that will be an identity here. Okay, so you just put this 1 minus 1 8 into here. You will see that this is 1 plus 5 into minus 1, and then you have 8. Okay, so you see that this is going to be 12. This is, yeah, this is 12 equal to 12. So either you do these two steps, number one, and this is your step number two. Like you check if the point lies on the plane, and then you check if their directions are perpendicular to each other. And this can be done in one step if you just put the whole of these parametric equations x, y, z into the plane, you end up with an identity. Okay. Now, in case of this red line, which is just parallel to the plane, this is just parallel to the plane. This is not entirely lying on the plane. So you will only have this dot product equal to 0. For instance, suppose if I change this equation with, let's say, this was instead of I minus j plus 8k, suppose this was 2i plus 3j minus 4k, and this direction vector is same. Okay, you see what will you get? Just wait. Okay, let me clear this. Okay, and this as well. Acha bacho, just see. Now you will have your x equal to, this is 2 plus 2t, your y is equal to 3, that's it, your z is equal to 8 minus t. Okay? If you substitute your point, these x, y, z into this plane over here, you will have 2 plus 2t, then you have 5 into 3, then you have minus 4 into 8 minus t. Just see what is going to happen. Okay, this is 2 plus 2t plus 15 minus 32, and then you have plus
Plus
4t.
40.
This is, it was 2 over here, है ना? This is plus 2. Okay, so this is 16 minus 2t, is that equal to 12? So guys, you see that 2t, this t is eliminated. Okay, and now you have this
33.
yeah, 33, which is not equal to 12. You see that if your line is parallel to the plane, this lambda or mu or this t, that will be eliminated, and the end result would be something where two sides, they are not equal, they are not identical. Okay? Now the third case, when your line is passing through the
Okay,
plane,
sir.
guess what would happen in the third case?
None of these would be the same. It wouldn't have its dot product wouldn't be 0, and nor would we wouldn't get an
Okay,
identity
okay.
either.
And what,
डायरेक्शन वेक्टर्स इक्वल होंगे नॉर्मल और उसके.
नहीं देखो, if you substitute x, y, z into the plane, what will happen?
We won't get an identity. We'll get the same sort of 33 is equal
ठीक
to
है,
12
ठीक है,
sort of
there will
thing.
be no identity. But the thing is, you see, when the line is passing through the plane, बच्चों, तो देखें होगा क्या? Like suppose there's a line like this. It is like, like this, and this is like this. Okay, it is passing through the plane. So when the line is passing through the plane, then there should be a point of intersection. And suppose that this is passing through the
Our
point.
variable won't be eliminated. We will still have the
Yeah,
variable
exactly.
lambda or something.
This t will not be eliminated, and you will get, in fact, I mean, a value of t. Now, suppose this r is, let's say, this r is I minus j plus 8k, and then you have 2i plus 3j minus k times t. Okay? You will substitute the xyz from here. Now your xyz would be, let me erase this, okay, and erase this as well. Okay, you see that now you have 1 minute. You have your x equal to 1 plus 2t, and your y is equal to minus 1 plus 3t, and then your z is equal to 8 minus t. And you substitute this into the plane. So this is 1 plus 2t and plus 5 into minus 1 plus 3t. And then you have 2 into 8 minus t, and that is equal to 12. So this is 1 plus 2t minus 5 plus 15t plus 16 minus 2t, that is equal to 12. Okay, 2t plus 15 is 17, and this is going to be 15t. Okay, 1 minus 5 is minus 4, and this is, yeah, this is 12. Oh, good. So we get this equal to 0. So your t is equal to 0. We get a value of t. Okay, t is not eliminated. So if you put this t 0 into here, okay, you get that point of intersection. So your point of intersection is going to be 1 minus 1 and this 8. This is the point of intersection of the line and the plane. And indirectly, you have learned how to find the point of intersection of a line and a plane. Okay, you just substitute your x, y, z from the line into the plane, and you will get that lambda. You put that lambda or mu or whatever that constant is there in that line into the equation of the line, you will get the point of intersection of the line and the plane. Yes, any questions, Bacho? Hmm? Okay,
Nope.
if there are no questions, so we can end this session and let's see what do we have next.